All right, guys, good morning, all of you. Very, very good morning. So, basically, in this session, we are going to continue our discussion. लेकिन आज का जो topic है, that is going to be organometallic chemistry. ठीक है? तो आज से जो basic organometallic chemistry है, those questions we are going to solve. ठीक है? So, yes. The session starts very soon. जिन लोगों ने already join नहीं किया है battle of questions, it is just like the live sessions that we are having over here, but those are mostly based on miscellaneous questions. ठीक है? तो जैसे हम यहाँ पे on our YouTube channel we are doing this topic wise practice. तो जैसे आज organometallic मैंने करवा दिया, ठीक है? So topic wise practice we are doing right now. लेकिन इन बोथ ऑफ दीज कोर्सेज स्पेशली द बैटल ऑफ क्वेश्चंस कोर्स जो आपका ओनली 101 प्राइस में ये कोर्स है. सो इन दिस पर्टिकुलर कोर्स आई एम मेकिंग यू डू मिसलेनियस क्वेश्चंस ऑफ द प्रीवियस ईयर्स. तो जिन्होंने पीवाईक्यू प्रैक्टिस नहीं किया है अभी तक, फॉर दोज हु हैव नॉट लेट्स से स्टार्टेड डूइंग देयर पीवाईक्यूज, दे कैन जॉइन दिस कोर्स. नंबर ऑफ क्लासेस आर लाइक अराउंड 10 to 12. ऐसा कोई वो नहीं है कि 10 ही क्लास मिलेगी. आई कैन मेक मोर क्लासेस इफ let's say more questions are to be practiced, and all the recent papers, all the recent year questions will also be discussed. Let's say your 2020, 2022 and 2023 वाले जो question है वो भी हम discuss करेंगे for organic and inorganic. ठीक है? So for those who have not yet joined this course, please do, because it's a very small investment that you can make for your making your preparation better. ठीक है? और ये वाला जो कोर्स है जिनको पूरा प्रॉपर क्रैश कोर्स करना था, that is the last minute practice for complete topic wise practice, those people have already joined this course. ठीक है? So that's it for now. These two courses are live on my app, which is Jagriti's chemistry classes. इसके अलावा for those who are looking for complete preparation जो जून 2024 CSI नेट के लिए देख रहे हैं, I will be launching a course within 2 to 3 days. मैं आपको पहले से ही बता रही हूँ, 2-3 दिन में हम प्रिपरेशन कर रहे हैं, उसी की चालू है प्रिपरेशन. 2-3 दिन में हम ज्वाइन कोर्स को लॉन्च करने वाले हैं फॉर द जून 2024, and in that course we are going to be discussing organic as well as inorganic. ठीक है? So yes, I hope that this is all that you need to know. अब हम start करते हैं. Let's start our preparation on organometallic chemistry. And today, since this is our first session, we are starting with a very basic set of questions. I have also uploaded 3 assignments जो PYQ assignments है. All of these assignments are previous year question assignments. I have uploaded these assignments in the group, and this consists of both the CSR net and gate question. तो ये जो telegram group है वहाँ मैंने डाल दिया है. So you can check out from there. ठीक है? चलो, let's start with our practice. First question. The correct combination of metal, number of carbonyl ligands and the charge for a metal carbonyl complex given over here that satisfies 18 electron rule is. Okay. All right. Chalo, first question. Very simple question, guys. You can answer. Very simple it is. 1 minute में आंसर हो जाएगा इसका. या लेट्स सी व्हाट इज द करेक्ट आंसर. तो फर्स्ट ऑफ ऑल हमें ये चेक करना है दैट आवर कम्प्लेक्स शुड आवर मेटल एंड द कार्बोनिल नंबर ऑफ कार्बोनिल एंड द चार्जेस ऑल ऑफ दीज शुड फिट इन दिस. ठीक है, तो ऐसा कौन सा मेटल हो सकता है? लेट्स ट्राई विथ टाइटेनियम. फर्स्ट वन, टाइटेनियम CO whole 6 and 1 minus charge. Is it going to fill out, is it going to follow 18 electron rule? टाइटेनियम के पास कितने इलेक्ट्रॉन है? दिस इज अ D4 सिस्टम. ठीक है, सो दिस इज बेसिकली D2S2, तो टोटल 4 इलेक्ट्रॉन हम काउंट करेंगे. 4 plus 6 into 2 is 12 plus 1. How many electrons do I get? I get only 17 electrons over here. Does not follow 18 electron rule. ऑप्शन नंबर बी में चेक करते हैं. Vanadium and hexacarbonyl and 1 minus charge. Vanadium has 5 electrons. 12 plus 1, this absolutely gives you 18 electron systems. Got it. B is the correct answer. इनको भी चेक कर लेते हैं. Cobalt tetracarbonyl 2 minus. So 9 electron plus 4 into 2, 8 electron plus 2. How much is this? 17, 18, 19. ये तो ज्यादा ही हो गया, 19 electron. What about the last one? Molybdenum pentacarbonyl 1 minus. So molybdenum has 6 electrons. 5 into 2 is 10 plus 1. ये हो गया 17 electrons. So only B is the correct answer. चलो move onwards. Next question. Complexes of general formula. Facial isomer of molybdenum, tricarbonyl, triphosphite have carbonyl stretching bands as given below. तो ये same question, this can be asked for the metal carbon stretching frequency, for the carbon oxygen stretching frequency, for the bond lengths and for the bond orders as well. तो ये सब चीजों के लिए ये सेम डेटा पूछा जा सकता है, राइट? सो व्हाट इज द करेक्ट आंसर? Yes. Correct combination of the phosphine and the stretching frequency. Everyone has to answer. Yes, Ritika, good. Depending on the atom to which the phosphorus is connected, depending on that, you are going to have the electron acceptance property, that is the pi back bonding property. So this is doing maximum pi back bonding from the metal. तो अगर ये metal है, ये phosphine है और ये हमारा carbonyl है. Okay, so if the metal is able to give back to the phosphine, ये हो गया sigma bond and ये हो गया pi back bonding. If it is able to give back to the phosphine itself, then there is very less electron density going towards the carbonyl. इसकी वजह से carbonyl का bond order is going to be high. So that is why PF3 is going to have maximum carbonyl bond order. That is why maximum stretching frequency, then the PCl3, then there is one Cl over here और ये तो pi acceptor बहुत poor pi acceptor है. This is a poor pi acceptor. So that is why lowest stretching frequency. So this is going to be as it is. A matches with 1, B2, C3, D4. ये बहुत simple answer है. चलो. So we move onwards. Number of metal bonds in the dimer here and here respectively are. Metal bond कैसे निकालेंगे? Try to find this out quickly. Using the 18 electron rule again, number of metal bonds are going to be found out. Yes, not that difficult, guys. So चलो let's try to find out. इतना भी मुश्किल नहीं है. So what are we going to do? The first complex is like this. You are having a CP which gives 5 electrons. You have iron which has how many electrons? 8 electrons. Carbonyl gives 2 electron, लेकिन nitrosyl कितने देता है? Let's assume it gives us 3 electrons. Okay. So if we consider this thing, तो कितने इलेक्ट्रॉन आ गए अंदर में? 5 plus 5 plus 8, it is already 18 electrons. So 18 electron को 2 से multiply करो, पूरा calculation करने की जरूरत नहीं है, because you got it that if it is already 18 electron system, there is no metal metal bond. Okay, zero metal metal bond. You only have it in option number D, isn't it? Zero. इसमें check कर लेते हैं. That is how many electrons are present in the monomer. 5 plus 6 from the molybdenum plus 6 again from the carbonyl. How many electrons are this? 6 plus 6, 12 plus 5. तो ये 17 electron हो गया है. Into 2 you are going to do. See, without like finding out the proper metal metal bond from the formula, what we can do is, we know that a compound has to have 18 electrons. Now how many electrons are short from 18? Only one. इसके लिए सिर्फ one metal metal bond बनेगा. That is why only one metal metal bond forms, और ये इसका आंसर है. ठीक है, चलो. So this is our correct answer, 0 and 1. We move onwards to our next awesome question. A compound A having the composition FeC9H8O3 shows one signal at 2.5 ppm and another one around 5.0 ppm in its proton NMR spectrum. The IR spectrum of this compound shows two bands around 1900 and 1680 centimeter inverse. ठीक है? Now the compound follows 18 electron rule of the following statement for A and the correct one is. ये थोड़ा सा लंबा चौड़ा question है, but this is nice. Yes, Ashika, done already. Yes. Yes, try it on your own. फिर देखते हैं इसको कैसे solve कर सकते हैं. All right, let's see. चलो, most of you are answering A. चलो देखते हैं. So first of all, it mentions the question is mentioning compound A having the composition. This shows one signal at 2.5 ppm and the another one around 5.0 ppm in the proton NMR. मतलब दो type के protons है. So we can assume that we have a eta 5 CP group. इसका formula क्या है? This is C5H5. Okay, and the overall empirical formula is given like this. तो इसमें से अगर हम C5H5 minus करते हैं, then we get iron C4 H3 and O3. From here we can remove iron, 1 CH3 and 3 carbonyls, isn't it? Then it is going to be C4H3O3. तो हमारे पास क्या हो गया? We have a C5H5, we have 1 methyl and we have 3 carbonyls. But there is a problem that okay, methyl की value आ गई 2.5, C5H5 आ गया 5.0. These are confirmed by the proton NMR. But the IR value is confirming only 2 carbonyls. We don't have 3 carbonyls क्योंकि यहाँ 3 carbonyl आ रहा है in the formula, but IR is confirming only 2 carbonyls. So what are we going to do? We are going to first of all write and see whether this is a stable complex or not. So we have 3 carbonyls like this. What are the number of electrons? 5 from Cp, 8 from iron, 1 from methyl and 6 from the carbonyl. कितने electron हो गए total? This is going to be how much? 6 and 6, 12. 12 plus 8 is 20 electrons. So this is not a stable complex. However, we have one more possibility. ये तो stable नहीं है, but since only two values are confirmed by the IR value, and in that also we see कि 1900 value is for the terminal carbonyls. ये 1900 value है terminal carbonyls के लिए, and the 1680 value is for a bridging or basically a carbonyl compound like this. ठीक है? So you are having eta 5 group. Very good. It has a terminal carbonyl ligand. It has a CH3 ligand. No, because it has a COCH3 ligand. Acyl है, methyl नहीं है, और direct iron hydrogen bond भी नहीं है. So A and B are only correct based on this structure. ठीक है? More questions like this you will get in BD Gupta chapter where it is already 18 electron rule. तो वो जो chapter है वहां आपको मिल जाएंगे BD Gupta में. More questions like this. Moving onwards, complex that does not obey 18 electron rule is. Alright guys, this is not that difficult too. Yes, very good, Ashika. Alright, very well, very good. Chalo, let's answer this now. So what are we doing? Complex that does not obey 18 electron rule. So we just have to count the electron. 5 from the Cp. Ruthenium के पास कितने electrons होते हैं? 8. Plus 1 from the chlorine, plus 2 from the carbonyl and plus 2 from the phosphine. तो ये तो एकदम plain simple है. We have 5 over here and 5 over here. So this is 18. This is 18 electron. तो ये हमारा आंसर नहीं है. Moving onwards, we have tungsten. Tungsten has 6 electron, chromium के group में है. 6 from the carbonyls. SiMe3 is a anionic group. This is just like a methyl. So this is only a 1 electron donor. Plus 1 electron from the chlorine. और ये क्या है last में? This is nothing but the cyanide. Okay, so this is just methyl cyanide. Okay, donating from the nitrogen side. So that is going to give you 2 electron. 2 into 2 will be 4. तो इसमें total electron कितने हैं? 6 plus 4 is 10 plus 6 plus 1 plus 1. Again 18 electron. तो ये भी गलत है because ये 18 electron system है. Moving onwards, iridium gives you 9. Chlorine 3 है तो 3 देगा. TPH3 gives you 2 electron. 2 into 2 is 4. Lastly, we have ASPH2. What is this? Arsenic diphenyl, ये anion है. This is an anion which is just like amide, because arsenic is present in group 15 and it has two groups, and that definitely means it has a negative charge. So ये anionic donor है, so plus one electron for this and one electron for the negative charge. How much is this? 9 plus 1 is 10. Then you have 4 and 4 18, so 18 electron system again. So C is again wrong, तो एक ही option बचा D, but चलो ठीक है, check कर लेते हैं. Osmium has 8 electrons, iron के group में है. This N means it is a nitride, N3 minus, so 3 electrons for the nitride, 2 electrons from bromine, phosphine से 2 electron, and again NMe2 is anionic donor, so only one electron we are going to consider, और एक negative charge के लिए एक और electron. So 8 plus 2 is going to give us 10, 3 plus 2 is 5, 5 plus 2 is 7, so 17 electron system है ये. That is why D is the correct answer. Got it? चलो let's move onwards. Next में, in the cluster, this is a cluster obeying 18 electron rule, the number of metal-metal bonds and the bridging ligands respectively are. ठीक है? ये बहुत ही सुंदर सा एक complex है. ठीक है? Just try to draw the structure also. Yes. Ashika, you're saying A. What about the others? Yes, Ritika, 2 बार A. चलो देखते हैं. So, we have cobalt. We have 3 cobalts like this, and we have 9 carbonyl, and we have a CH. तो ये स्ट्रक्चर है ना, इसको दिमाग में फीड कर लो. Why? Because this is necessary. It is CO4 CO whole 12 से we have removed one of the fragments from here. What fragment have we removed? We have removed one CO whole 3. ये fragment हमने यहाँ से minus कर दिया है, and we have replaced this fragment with a CH to finally give you CO3 CO whole 9 CH, because this is isolable to CH. ये वाला fragment जो है, इसको याद कर लो. Just remember this. Okay, कुछ दर्द नहीं होने वाला है आपको याद करने में. ठीक है? And it is going to be helpful only. So ultimately what happens over here is, in our this complex CO4 whole CO whole 12, ये complex कैसा है? This is nothing but like this, that you are going to first form a tetrahedral system of using 4 of these cobalt. ऐसे करके tetrahedral बना दिया. Tetrahedral में कितने bonds होते हैं? There are 6 metal bonds in the tetrahedral system. Now, definitely there will be some bridging carbonyls also, but I am not taking any headache about it. उसके बारे में हम बाद में सोचेंगे. एक simple सी चीज ये है, the bridging carbonyls will be confirmed by the IR value. This is not the exact structure of this complex. Why? Because I am not considering the bridging ligand. लेकिन overall अगर देखा जाए तो each cobalt is going to have 3 metal bonds plus 3 carbonyls. ये एक each cobalt is going to have this. ठीक है? So I have removed this fragment from here, CO whole 3. ये fragment हटा दिया and I am putting a CH over here. What do you get? You are going to write the same structure. Skeleton same है, but here you are just having a difference like this. ठीक है? So in the cluster obeying the 18 electron rule, the number of metal-metal bonds and the bridging ligand respectively are. This is the bridging ligand absolutely. ठीक है? सिर्फ CH के बारे में बोल रहा है ये. Obviously there are carbonyls also which are bridging. लेकिन number of metal-metal bonds सिर्फ 3 है. 3 metal-metal bonds like this. And this has to be the bridging ligand. If you mention the carbonyl, if you don't mention the carbonyl, no worries. तो इसमें भी confusion हो सकता है that 3 metal bonds are present. एक carbonyl bridging है. अब carbonyl के बारे में बताओ या नहीं बताओ, CH के बारे में बताना जरूरी है. So C is wrong. You have to mention this. So this is the correct answer. Option number A. Why D will be wrong? Because there will be 6 metal bonds if you are having this complex. ठीक है, इन दिस कॉम्प्लेक्स यू वोंट काउंट दिस बॉन्ड एज अ मेटल मेटल, ये तो CH है ना, दिस इज अ ऑर्गेनोमेटेलिक फ्रैगमेंट, सो दिस इज रॉन्ग. ठीक है, वेरी नाइसली आंसर्ड. ऑप्शन इज ए इज द करेक्ट आंसर. लेट्स मूव ऑनवर्ड. करेक्ट ऑर्डर ऑफ मेटल कार्बन बॉन्ड लेंथ ऑफ मेटलोसीन्स फ्रॉम A to C. ओके, metal carbon bond length. Okay, that is what you have to answer. So let's see. Iron has 8 electrons and eta 5 Cp, again this is going to have 10 electrons. ठीक है, तो ये हो गया 18 electron system. Yes Ashika, let's see. तो ये 18 electron system है. Now nickel over here, nickel has how many electrons? 10. और क्योंकि ये जीरो ऑक्सीडेशन स्टेट में हम अगर इसको रख रहे हैं न्यूट्रल मेथड में, दिस इज 10 and this is going to be another 10, so this is a 20 electron system. Cobalt 9 plus 10, 19 electron system. So 18 electron system is the perfect one. अब इससे ज्यादा इलेक्ट्रॉन हो जाएंगे तो these electron, the 1 electron over here and the 2 electrons over here, these are going to go into the anti-bonding orbital. So once they are going into the anti-bonding orbital, इसकी वजह से क्या होता है, the bond order is going to decrease and the bond length increases. So maximum bond length of metallocene किसकी सबसे ज्यादा होगी bond length, guys? You say based on the answer, based on the number of electron, किसकी सबसे ज्यादा होनी चाहिए bond length? Definitely B. Maximum electrons in the anti-bonding orbital, then comes C, and A is perfect. A is 18 electron system. ठीक है, so B is the correct answer. Okay, now we move onwards to another one. Bond order of the metal bond in dimeric complex over here is, और यहाँ एक positive है. Okay, ऐसे ये वाले compounds बहुत आते हैं. Many a times these have been asked in your exam. All right. So this complex looks very similar to the one which forms the delta bond, isn't it? देखने में तो वैसा ही लग रहा है, रेनियम का कॉम्प्लेक्स है. क्या हो सकता है? This one is looking very similar to this compound, but there is a positive charge over here. Yes, hello Ritik, how are you? Good morning. All right, so we are practicing organometallic chemistry questions. बेसिक से स्टार्ट किया है आज हमने, इसके बाद में हम और भी एडवांस वाले क्वेश्चन लेंगे. So basically today we are talking about structures. B is the correct answer. Let's check. तो ये देखो, we are having rhenium and see all the phosphine is basically this is just having a neutral. This is just a neutral complex. ठीक है, तो phosphine तो neutral donor होते हैं. Cl4 is actually Cl minus. ठीक है, either you can find out the oxidation state, वैसे निकाल सकते हो, या फिर हम total number of electrons से compare कर सकते हैं. See here rhenium is 2 and Cl8 2 minus. तो इसके पास total electron क्या है? Total valence electron with this rhenium is there in the manganese group. So manganese have total of 7 valence electrons. 7 into 2 is 14 plus 8 from the chlorine plus 2 from the negative charge. कितने electrons है? 24 electrons. So 24 electron has a delta bond because you know this has a delta bond. इसको कंपेयर करते हैं. टोटल वैलेंस इलेक्ट्रॉन्स आर हाउ मच? So 7 into 2 is 14 again plus 4 from the chlorine plus 4 into 2, क्योंकि यहाँ पे देखो क्या है, phosphine gives 2 electrons, so 4 into 2 8 electron minus 1 for the negative charge. तो ये कितना हुआ? 18 plus 8 minus 1. 26 minus 1 is 25. So you have only 1 electron extra. तो अगर हम देखें sigma pi delta delta star. So if you have just 1 electron extra, let's say you don't want to draw this, आपको ये draw भी नहीं करना है, तो भी हमें पता है that for each extra electron, if we are putting 1 electron in the anti-bonding, एक electron के लिए 0.5 bond order minus होता है. So that is why the delta bond means bond order is equals to 4 over here. एक electron extra है, reduce minus 0.5 from that, that is going to be 3.5. Got it? तो ये जो क्वेश्चन है इसका आंसर है 3.5 बॉन्ड ऑर्डर फॉर दिस वन. लेट्स मूव ऑनवर्ड्स. ये देखो, अगेन सिमिलर क्वेश्चन. द कंपाउंड ओवर हियर having a electronic configuration which is given can be oxidized to metal positive and metal 2 positive. The formal metal metal order in अच्छा सॉरी metal complex लिखा है overall M. So metal complex, then having a positive charge, then having dipositive. इनमें सब में bond order निकालना है. What are the bond orders for all of these three species? Okay. Yes. Same question. So you just found out Re2, Me2, P, PH. Again a neutral phosphine. Whole 4 and Cl whole 4. Total valence electron कितने हैं? That is rhenium 7 into 2, 14 electrons, plus how many phosphine donors are there? 4. So 4 into 2, 8, plus 4 again for the chlorine. कितने electrons हो जाएंगे total? This is going to give you 26 electron total. So this is M. Now it has 2 extra electrons from 24. अभी अभी हमने देखा that 24 electron count is going to give you a bond order of 4, which we already know exists in this one. ठीक है, तो 24 से कितना ज्यादा है? 2 electrons. 2 electron extra means the bond order is going to decrease by 1. ठीक है, so the bond order is going to be 3 for this. ठीक है, आगे बढ़ते हैं. If I am removing 1 electron, so M positive is going to have 25 electrons. So 1 extra electron, and that is why the bond order is going to be 3.5. and M2 positive में कितने electrons है? 24 electron. Perfect. So there are going to be 24 electron, no extra electron. The bond order is going to be equals to 4. So respectively पूछा है 3, 3.5 and 4. A is the correct answer. Got it? एक बार check कर लेते हैं once again. 14 electrons and 8 electron and 4 electron like this. Okay. And this is going to give you 14 plus 4, 18 plus 8, 26 electrons here, 2 electrons extra, 3.0. फिर ये आ गया M positive 25, 1 electron extra 3.5, then M2 positive 24 electrons. Okay, so the answer is option number A only. आगे चलते हैं. Okay, and one more thing guys, यहाँ पे total valence electron निकालने की जरूरत नहीं है. No need for finding out the total valence electron. Also, it is just a method that we have developed. That's why we are doing it. In this question, it is already given. For M, it is already given that there are 2 electrons in the delta star. 2 extra electron matlab bond order is going to reduce by 1. Okay, so from that also you can confirm. Very easy question. आगे चलते हैं. According to isolable analogy, the right set of fragment that might replace this in this is. So just now we have done a question on this. तो उसी को लेके you can answer. Okay. Yes. All right. So easy question. Answer quickly, guys. अभी अभी किया था ना? Just done in the previous slide. So this structure also we have discussed. That is, this is going to be isolable with a CH fragment. Just now we discussed this one. Now what is CH isolable to? CH के पास कितने electrons है? 4 electrons from carbon, 1 from hydrogen, 5 electrons and 3 holes. That looks similar to a group 15 element, isn't it? This is going to be isolable to a phosphorus. Has the same number of electrons and same holes. इसके अलावा चेक करते हैं निकल वाला कॉम्प्लेक्स. तो निकल eta 5 Cp 10 plus 5 gives you 15 electrons. 18 minus 15 is equals to 3 holes. That is 3 electron deficiency. So the correct answer is going to be B. Very nicely answered, all of you. Very good. Very, very good and very fastly we have answered. आगे चलते हैं next question. According to Wade's rule, correct structural type of this complex and this complex are. Yes. Correct structural type according to the Wade's rule. So what do we do, guys? Wade's rule तो boranes के लिए होता है ना. So what do we do over here? We are going to convert this fragment into boron unit. कैसे करेंगे? Cobalt has 9 electrons and eta 5Cp gives you 5 electrons. How much is this? 14 electrons. 14 electrons, how many holes? 18 minus 14 is 4 holes. तो बोरॉन का ऐसा कौन सा स्पीसीज है? A BH3, a simple borane. That is a Lewis acid, you already know. So it has how many electrons? 3 and 3, it has only 6 electrons. And 8 minus 6 is 2 holes. So borane itself has 2 holes. अभी इसमें हमें, if I'm like removing 2 hydrogens from here, that will give me 3 plus 1, 4 electrons and 4 holes. तो इसलिए I'm going to replace this with a BH unit. ठीक है? तो क्या बन जाएगा? BH B4H8, that gives you B5H9. What is it like? This is nido. Nido क्या होता है? देखो क्लोजो क्या होता है? BnHn plus 2 is clozo. BnHn plus 4 is nido. So the first one, this one is a nido. इसके बारे में देखते हैं. मैंगनीज eta2b3h8. What is eta2b3h8? That is, it is only a 2 electron donor. बस इतना ही जानना है आपको. So 7 plus 2 is equals to 9. ठीक है? या फिर हम एक काम कर सकते हैं. Let's say इसको हम अवॉइड करते हैं. eta2b3h8. We will take मैंगनीज. थोड़ा सा कंफ्यूजिंग है ये वाला. So इसको हम पहले ऐसे लिखेंगे. MnCO whole 4, because we will always take the organometallic fragment on one side and the borane fragment on the other side. ठीक है? We write it like this. Manganese gives 7 electron, 4 into 2, 8 electron from here. कितने electrons हो गए total? 15 electrons, this one. So 15 electron means BH3 has 6 electron, 2 holes. BH has 4 electron, 4 holes. A BH2 fragment. A BH2 fragment will have 3 plus 2, 5 electrons and 3 holes. So यहाँ पे BH2 लगेगा because this has 3 holes now. So I'm going to put a BH2 fragment over here, B3H8. इसको totally combine करेंगे तो B4H10 हो जाएगा. That is going to be arachno. So the answer is going to be, you tell me the answer, nido and arachno, isn't it? So the answer is option number B, nido and arachno. Got it? Very well. Very nicely answered. Yes. Acha, दूसरा, next question. The number of nickel-nickel bonds in this complex obeying the 18 electron rule is? All right. Simple question. Yes. So again, what is this mu? Mu is for bridging. So Cp nickel and we have two of these units. अगर इसका structure draw करने की कोशिश करें, if we try to draw the structure, how is it going to be? You are having Cp nickel, that is 5 plus 10. This is a 15 electron species combining this. And you are having a bridging ppH2. Mu ppH2. वैसे भी देखो, ppH2 means it is a minus and it also donates from the lone pair. So how many electrons are we going to consider for this unit? Neutral method may 1 electron for the negative charge and 2 electron for this. So it is donating from both the sides. So there will be 3 electrons that we are going to consider. So Cp Ni, that makes 15 electrons plus 3 electrons total. So this is a total of 18 electron. Already this is a total of 18 electron system. तो कितने nickel nickel bond होंगे? 0 nickel nickel bond. A is the correct answer, guys. Okay, A is the correct answer. There is no nickel nickel bond. So if there is no nickel nickel bond, तो ये dimer क्यों है? You might be confused about this. Why it is a dimer then? It is a dimer because only the phosphorus is donating. Got it? ऐसे. So there is no nickel nickel bond. The complex structure is actually going to look like this. ठीक है? Phosphorus being working as a bridging ligand. चलो आगे next question. The reaction of nitrosyl tetrafluoroborate. What is that? NO plus BF4 minus. बस यही है. अभी आप 1 घंटा इसको find out करने में लगा दोगे कि ये क्या है. So I'm already mentioning nitrosyl tetrafluoroborate. 2 Vasca's complex gives a complex A with the metal nitrosyl bond angle 124 degrees. The complex A and the nitrosyl stretching frequency are respectively. ठीक है? Yeah. You have to tell me this one. Very easy it is. Yes. Okay. Exactly. See, what is the Vasca's complex? Vasca's complex is nothing but the trans complex of iridium, phosphine, chlorine and a carbonyl. ये 16 electron species है. If this is 2, 16 electron species, it is very stable क्योंकि जो D8 system हो जाते हैं, those are very stable at 16 electrons. So, if this is to react with nitrosyl, it will get a overall positive charge and it will still try to remain a 16 electron system even after reacting with nitrosyl. When it is possible? It is possible when the nitrosyl is giving 1 electron and 1 electron is cancelled out by the positive charge. तभी ये 16 electron system रह सकता है. If you consider कि nitrosyl is a 3 electron donor, then it is not possible. And we also confirm this कि nitrosyl एक ही electron donate कर रहा है based on the bond angle. Because when we are having a bent nitrosyl, then the nitrosyl is only a 1 electron donor. We get this from the bond angle, isn't it? So the actual structure of this molecule is like this. Nitrosyl ऐसे है, bent है. ठीक है? So this is your molecule. Now bent nitrosyl is going to have a lower stretching frequency that is 1620 and only one nitrosyl will add. ठीक है, ये देखो दो नाइट्रोसिल ऐड हो गए, wrong, two nitrosyl wrong, and here 1820 centimeter one nitrosyl, absolutely wrong. So this is a 16 electron system and the answer is option number A. ठीक है. So guys, today we have done a lot of questions, almost 1 hour practice हमने कर लिया है. ठीक है, and tomorrow, day after tomorrow, we are going to continue our discussion on organometallic compounds. The timing will be the same. I am having morning sessions from now onwards. ठीक है, अब से जो classes चलेंगी, live classes, these will be in the morning only. All right. And for those who have not already downloaded my app, please do. There are some free assignments to practice from. तो वो जो असाइनमेंट है वो फ्री है सारी, आप लोग डाउनलोड करके देख सकते हो, पढ़ सकते हो, प्रैक्टिस कर सकते हो. यू विल गेट इंपॉर्टेंट बुक्स फ्रॉम देयर एज वेल. एंड फॉर दोज हु वांट टू बाय दिस बैटल ऑफ क्वेश्चंस, जो कि आपका सिंपल सा प्रैक्टिस मिसलेनियस क्वेश्चन प्रैक्टिस का कोर्स है, you can buy this small course before your exam also. All right, so I will see you all in the next session with a new announcement. We are launching a new course for the CSIRNet June 2024 preparation. तो उसके लिए भी मैं जल्दी से announcement करने वाली हूँ. Stay tuned everyone and keep practicing. So now I'm going to see you all tomorrow. Okay, so have a very nice day guys. Bye everyone, take care of yourself and yeah, keep studying.